Welcome back to our R adventures. This video, two relatively small things I want to talk about. One is the for loop in R. The other is simulating random variables. So the for loop is a type of operation that is very, very useful if you want to repeat the same operation many times and you know ahead of time how many repetitions you want. Okay, so let's start with a very basic example and explain the syntax. So the syntax is this, and you see for is in blue because it's a keyword. Like so R, it has a certain meaning to for, a bit like return or function or those things we've seen before. Okay, so for, then brackets. Now here, this you could call this an index. You can give it whatever name you want. Okay, here I call it I, or often you could call it J or something. But if you call it J, of course you need to update it everywhere. Okay, so let's call it J. This is gonna run for every integer in the integers you specified here. So J is gonna run from 1 to 10 by steps of 1. Okay, so the syntax is then bracket J in, that's another keyword in blue, 1 to 10. Okay, I could have done something else. I could have done 3 to 7. Okay, but it goes in steps of 1. Now, what is this? I'm going to go back to 1 to 10. What this do then is that we have again the syntax curly brackets, and whatever's in the curly brackets, that's the crucial part, is going to be repeated for all the values of J, again by increments of 1. Okay, so coming back to what I said before, we're doing the same operation, but each time we update the value of J. Okay, and that in many contexts is quite useful to do. Okay, so let's just try it. And here, print is just displaying the value. Okay, so print is just displaying the value. So let's run this. Okay, so again, you can run it. Okay, and the result is here. J goes from 1 to 10, and what I'm printing is just J squared. Okay, so then of course I'm going to get 1, then 2 to the 2 is 4, 3 to the 2, etc. Okay, so a very simple first application of this for loop. Again, I've repeated an operation here for the index that goes to 1, 2, up to 10. Okay, obviously you can do whatever you like. Okay, you could have had this, and let's say that I just want the values from 3 to 7. Okay, I'm doing. Okay, then I'm gonna get 3 to the 3 and 4 to the 3 and etc. Okay. Now, by the way, this, maybe you don't need a for loop if you actually want to do that, because you have the nice vectorized behavior of R, meaning that, if I had created a vector of 1 to 10, okay, I can apply it to the operation square, and this is going to also give me all the values. But now it's giving me all the values in a vector. Okay, so it's slightly different. Print is just displaying in the console. So here, if I want to create a vector of those values here, I could. And my point is just that in this simple example, I don't really need the for loop. Okay, this example is more for pedagogical values. Okay, now doing this, I have a vector I can reuse, the vector of all the squares up to 10 to the 2. But now let's give a slightly more complex example, which is finding the first 10 Fibonacci numbers. Okay, so in case you don't know, the Fibonacci numbers are a very, very famous sequence of numbers in mathematics. Maybe I'll take a second to show you that we know it's famous because it has here a Wikipedia article. But so the sequence is as follows. It starts at 0, then 1, and then every single number in the sequence has the same pattern. It's just the sum of the previous 2. Okay, so of course the sum of 0 and 1 is 1, but then the next number is the sum again of the previous 2. So 1 plus 1 gives you 2. Okay, etc. 1 plus 2 gives you 3. 2 plus 3 gives you 5, and so on. Of course, the numbers get bigger and bigger and bigger. Okay, so we just want to find a sequence automatically by our code. That's our mission. I hope you accept it. So back to R. This is a pretty textbook example of a for loop application. because you see, we just want to do the same operation of finding the sum of the previous two numbers, and we want to do this a set number of times. Okay, now just a bit of syntax. There's many ways to declare a vector, an empty vector, but a common one is just to use the syntax C. So recall that C allows you to create a vector, but if you put nothing in between brackets, then it creates an empty vector. And this syntax actually, so now I've created Fibo. Fibo is now empty. So if I type Fibo, there's nothing there. It says null. But this allows you, but R still knows that Fibo is a vector, so you can add numbers to it. Okay. So if I create, I wanna put into Fibo numbers sequentially. Now the first two, we do this kind of manually. Okay, we don't use the for loop yet. So you can tell R, okay, the first element of Fibo should be 0. Okay, so if you do that, it works. Okay, R is gonna take Fibo, which is currently null, and then create a first element. So now Fibo has one element, which is 0. But then you can keep going. Fibo 2, the second element in our Fibo vector, we want it to be 1. Okay, and if we do that, now we have a vector of two values, 0 and 1. And now this is where our for loop would kick in, because we can then, if in this example we want to find the 10 first, if we've manually find the first two, but then we want to find the next 8 using our for loop. And so it would go like this. 4. Now we're going to run, again, this you could call it whatever you like. Let's have it be named I. So I is going to go from 3 to 10. And now, careful here, the syntax would mean Fibo I would be the ith element of the vector Fibo. If we start at 3, that's good because we already have the first two. Now, Fibo ith, you define it, okay, that's how we create the Fibonacci number, to be the sum of the previous two in the vector. So of course, the very first value in the loop, the for loop would be 3. So then Fibo 3 would be Fibo, 3 minus 2, so the first one plus the second one, and that's it, okay? But the magic is that R is once you've defined Fibo 3, and you go back and you feed to the loop the second I value, which in our case here would be 4, well, Fibo 4 is function of Fibo 3, but Fibo 3 has been defined, so now you can keep going. And you keep going, and up to the last one in our case would be Fibo 10. Fibo 10 will be then Fibo 8 plus Fibo 9. Okay, by Fibo 9, I mean the 9th value in the Fibo vector. And if you do that, and at the end, I just display here Fibo. Now, of course, I set here 10, but you could have done this for the 50 first numbers, and then you would just run from 3 to 50 here. And of course, you could have done this in the, maybe it would have been slightly more elegant to do that within a function, and the function as an argument, how many numbers you want. Maybe I leave you that as an exercise to try to define a function that displays how many numbers. Okay, and you see that here already with 50, it gets to pretty large numbers. Okay, I think that's it for the for loop concept. Okay, you repeat an operation for as many times as you want based on what you've entered here. Another small point here that is important, I think, is that R is pretty good at simulating random variables, as we have done in Excel. But let's see how this works in R. There's already pre-written functions that allow you to do this for many common distributions. Okay, so let's just see maybe 2. And but the syntax is always the functions are the syntax that starts with R and then some sort of abbreviation for the name of the random variable. So R norm would of course simulate random variables from the normal distribution. And here the arguments, by the way, I should have said this before, but the arguments of a function, if you don't explicitly enter their name, it's fine as long as you have the right order. Okay, meaning that the order of the arguments for the R norm function, and if you want to have a bit of information about this function, you can type in the console R norm and R norm. This should give you a bit of information on the right here. Okay, you're gonna have the basic description of the function. So R norm is here. So the order of the arguments are how many variables you want to simulate. So n is how many you want, and then the mean, and then the standard deviation. So this code here works, is going to generate 10 normal random variables. Okay, but my point is that as long as you have the right order, R understands that here what you mean is you want 10 standard normal with mean 0 and standard deviation 1. Okay, and if you type here maybe a standard deviation of 10 and a mean of 100, then you're going to have, of course, values that are closer to 100. Okay. That's our norm. I'm not going to say much more about this. And then there's others. Okay. If you want to generate the exponential, again, the first argument would be how many you want. And then the rate is the parameter we've called lambda in this course. Okay. The only parameter of the exponential distribution. Again, if you want to find a bit more information, you can type question mark exp. Sorry, should be rexp. Rexp. Okay, because there's other functions like to find the density, the CDF, and the quantile function. I'm not going to cover them here. I'm just covering the generation of random numbers. Now, if you want to see the results, okay, so maybe you've generated a few. Let's say I generated 1,000 random normal, standard normal values. I'm going to declare this in the vector. So now my rand vector contains those random values for the normal. You can do, there's a command, again, I'm not using ggplot2, I'm just using base R, so I don't need to install any package. So histogram would simply be the histogram, let's make this slightly bigger. Okay, histogram of all those 1,000 values I've generated. Again, if you want to play around with the display of histogram, you can. So here it's the same thing. I'm going to display my 1,000 values for the standard normal, but with different things. So I change the color of the histogram. I make the number of breaks a bit bigger now. 100 breaks is probably too much here, but let's still try. I don't especially like to have an X label here, so I'm going to make the X label empty. I want to display this on the probability scale, not on a frequency scale, meaning I want to see the shape of the density. And then I'm making the label a bit bigger, and I'm giving a title to my my histogram. So let's try this. Okay, you see, number of breaks is probably a bit too big, so let's say 30. Okay, and then if I guess the strength of R is that you can generate many, and it's relatively quickly up to a pretty high number. So if I generate 100,000, this should also be pretty quick. So I'm going to update this. Okay, generate 100,000. Then here, because I have 100,000, 100 breaks, 100 brackets, it's probably good. And you'll see that it should have a shape very, very close to the normal. And yes, I'm very proud. Look, mom, my first R histogram. Okay, and obviously you can change. So brown tree is my favorite color, but you can try other ones. The colors in R have funny names. I mean, some of them have funny names. I guess light green is not especially funny, but yeah, things like that. Okay, I think that's probably it. Let's just try just for fun. We're having so much fun. Let's try for the exponential. Okay, what's going to be the shape of the exponential? Okay, something like that. Now, if you think it's going too far here on the tail, you're not especially happy because it's kind of, you don't really want to display any values after 60 because there's almost none. You can play around with the argument. I think it's xlim. So I'm specifying the range of values to display. So from 0 to say 60. Okay, something like that. Okay, I'll stop here. I'll make one final video where we're going to do a slightly more complex example and try to put all of that we've learned together, creating functions, simulating random numbers, and using the for loop. Okay, so in one last example, we're going to redo this problem from the week 6 tutorial. And we'll see it's going to be a slight challenge, but we're up for it. I'll do that in a different video. Bye-bye for now.